Welcome to this tutorial on how to make a metal water bottle. Before we begin, I want to give a fair warning that now that we are deeper into the semester and have already gone through quite a bit of tutorials, I will not be calling out every transform tool and their shortcuts, because it is expected that now you know that if you want to select something, it's 9 on your keyboard for the live selection tool. If you want to move something, it's E on your keyboard for the move tool. If you want to scale something, it's T on your keyboard for the scale tool, and if you want to rotate something, it's R on your keyboard for the rotate tool. Alright, so back to the tutorial. On the Maxon site that discusses the volume builder, I saw two very different models that could be created using it, and I thought it would be fun to recreate them both. The first one is the water bottle and the cap of the water bottle specifically, which unfortunately, while they do have a video, they really are only putting already made objects into the volume builder, and I didn't want to be cruel and give that to you, so I am recreating it here. And then the second one is this little lady ice cream on the left side of the screen. So both of these models are created using the volume builder, but they're both quite different. The bottle is hard surface modeling, which means that it's an inorganic model. So something like a building or a machine would be considered hard surface modeling, while the ice cream falls more under organic modeling. So things like characters, humans, animals, all of those would be considered organic. We're going to start modeling the cap of the bottle. To begin, take out a cylinder object and make it smaller in the height to around 85-87 centimeters. Next, we are going to use a cube to shape the sides of the cylinder. Let's shape it to 85 centimeters in size X and Z and 120 centimeters in size Y. And then let's bring it down a little bit below the top of the cylinder. Bring in a taper deformer and make it a child of the cube. We want to make the bottom of this cube bigger than the top, and because the taper only works on the top portion, we're going to need to rotate it with your rotate tool so that we can alter the bottom and make it bigger. Rotate it 180 degrees and then alter the taper so that the bottom gets bigger. I left it in -45%. Now we're going to make some drastically beveled edges by checking on fillet in the cube and turning the radius way up to around 25 centimeters. Of course, we also need to increase the segments because we need this to be a smooth bevel. Alright, that's looking good. Let's hide the taper deformer in the viewport. Organize our object manager with proper names and begin using the volume builder. Because this is hard surface modeling, we want our pieces to not be soft geometry, and if we leave our voxel size as is, when we turn it back into geometry, it will only calculate the big boxes of voxels and it will be too smooth. So we need to reduce our voxel size. We can start with 1 centimeter to not overwhelm our machine, but later on we will need to go lower. Now, the Boolean operation that we want to happen between these two objects is the intersect, which will leave behind only the parts of the cube and the cylinder that are intersecting with each other. This is going to give us our basic shape for the cap of the bottle. As a reminder, you can still alter the shape after you put these into the volume builder because it stays live. But do remember that it is difficult for your computer to calculate all of these voxels moving at the same time. So later on, when we have a lot of objects and you need to make changes, I would recommend that you deactivate the volume builder and the volume measure when we get to that before you make a change. I am going to leave this on the screen for a second so that you get an idea of the shape that we are going for. Now let's switch to the front view, and to see the shape in the front view we actually need to deactivate the volume builder for now, because the front view is in a specific display mode that does not show you voxels. Now we want to cut a shape by creating a spline with our pencil. So let's create this triangle. And now let's round out this bit with the spline arc tool. Let's size and place this. And everyone's going to have different sizes and shapes, so don't worry if it doesn't look exactly like this one. We are going to use this spline to cut out the sides of this shape. So let's make the spline a child of an extrude, and then make the extrude big enough so that it covers the entire object. We want both sides to be cut out in the exact same way, so let's use a symmetry object for this. Make the extrude a child of the symmetry, and there we go. We have a perfectly symmetrical shape on the other side. Let's bring this into the volume builder, activate the volume builder, and now the Boolean operation that we want for this is subtract. You can edit the spline after the fact to alter how the cut looks by going to your selection and selecting the specific points. Remember that to select specific points, you should be in point mode, not in model mode. Let's make this hole in the middle with a cylinder object. Change the radius to 26 centimeters and the orientation to +x or -x. And in all of the pictures that I saw, it was never a perfect circle. So let's bring out a bulge deformer, make it a child of the cylinder, and bulge it in the positive to 17% or something around that. To have a smooth bulge, let's increase the rotation segments of the cylinder. Bring it into the volume builder, and the Boolean operation subtract. Alright, so we're going to repeat this exact step, but make a smaller cylinder that we're going to later on put a keychain ring onto it. So bring out a cylinder, put it in the correct plane, make it smaller, and bring it into the volume builder as a subtract Boolean operation. Right here, I'm just making small changes to the object's position in Y so that I can adjust the way that this shape looks. Make sure that you guys always name everything. And I know that what we're doing here is just using a lot of little bits and pieces that we don't necessarily know what their actual name is, but we need to be as descriptive as possible so that later on, if we want to come back and alter, let's say, the cuts that we made on the sides, we know to look for the side cuts. Now, let's make the bottom part of the cap. Take out a tube object and let's shape and position it below our already built portion. After a bit of adjusting, I ended up with an inner radius of 30, an outer radius of 35, and a height of 33. Bring it into your volume builder and let's move on. Since by default things get added with a union operation, and that's exactly what we needed. Now let's take out a helix, put it in the correct plane, which is XZ. I want this helix to be the screw portion of the cap. So first, let's scale it down and then begin altering the helix. The start and the end radius should match, so let's make both of them 35 centimeters. We also want a lot more turns, so I'm going to increase my end angle to around 2000. I left mine at 1820, but there's no perfect number. You can do higher or lower depending on what you like. And let's make it smaller, so decreasing the height to 28 centimeters. Once it's all done, let's bring it into the volume builder. The volume builder generates geometries for splines that you add into it, which is pretty cool. But as you can see, it's hard to decipher, so it's time to reduce the voxel size to 0.5 centimeters. However, if your computer is giving you issues, you can leave it at 1. At this point, I'm just positioning things a little better. So like I mentioned, the volume builder generates voxels for splines, and we can alter how it's being generated with these options down here. The way that it fills these up is with a bunch of little spheres, and the radius decides how big the spheres are, while the density decides how dense. If you reduce the density too much, you can actually see the individual spheres. Let's leave this at radius 1 and density 5. Let's also edit the scale along spline down here. You can zoom out and pan similar to how you do it in the viewport using the shortcuts. So 1 or 2 on your keyboard, or Alt and middle mouse button and Alt and right click on your keyboard and mouse. Let's alter both of these tangents to go upwards because I like the size that it has right now. So I want my ends to stay that size, but for the middle part to get bigger. So what this is going to do now with the curve is that both of the ends are at the same exact size, and then it's going to get bigger towards the middle and then back down to the same size. Now let's be extra and add a detail on the inside of this cap. Take out a cube and make it small enough so that it fits inside of the cap. Now let's make it long in Y. The exact size that I have is 3 centimeters in X, 23 centimeters in Y, and 4 centimeters in Z. Using the move tool, let's move it so that it fits inside and touches the top part. Once it's positioned, let's make a symmetrical object of this so that it also goes on the other side. So take out a symmetry object and make the cube a child of it. Once we have the original and the symmetry, we want to make an instance of the symmetry, which will give us an instance object that has 2 cubes in it, which are the original and the symmetry. Now we are going to rotate the instance to 120 degrees around Y. The reason for this is that we're going to do this 3 times, and we have a 360-degree tube. So we need to make sure that they're all evenly spaced out. So the first one is going to be 120 degrees. And now let's create a second instance. And rotate this one to 240 degrees. Look around and make sure that they're all in there and that they were only rotated in one direction. Let's group these guys together into a null named inside bits and bring it into the volume builder. Just need to add one more detail. So let's cut off the bottom of this so that it can't be that clear where the tube and the helix end. Let's use a cube for this. Bring it in and subtract Boolean operation. Now you can move it around so that you can see where it looks better. You don't want to cut off too much, but cut off a little bit of it just to make sure that you can exactly tell, like, okay, here's where the helix starts. It's totally CGI. Let's add a folder to the volume builder so that we can separate the bottom part from the top part. Bring all of the bottom parts in and make sure that they are in the right order. Remember that the volume builder works in a layer system. So if you put something that is meant to subtract and it's not in the right layer, it could remove more than you want. Once that's done, let's add an SDF smooth filter and bring it into the folder so that it only affects the objects in this folder. Remember, it has to be the upmost layer of the folder. We are using this smoothing to merge the helix and the tube together a little better. Let's change the smooth operator because Gaussian is just a bit too soft and used more for organic shapes. We're going to use mean curvature, which allows you to still have sharp edges. Increase the iterations, which is how many times the smoothing is happening. Okay, so if you notice, the volume builder with a small voxel size reveals all of the segments of your object. The smoothing will help us, but because this is not meant to be an organic shape, we can only smooth so much. So let's quickly go into our tube attributes and increase the rotation segments so that the rotation is smoother. Let's add another smooth filter for that cylinder that's making the big hole. Since it's just a cylinder, we can go quite drastically, but let's make sure that it doesn't affect anything else. So let's isolate it by putting it into a folder and bringing in a smooth filter. Make sure that you change the Boolean operation on the folder because by default they come out as union as well, and we want this whole to be subtracted. If it isn't enough, then we can always increase the segments of our cylinder because the more segments, the smoother the cylinder will be and the less you will be able to see them on the volume builder. Now let's add one last detail, some bumps on the side of the cap. Bring in a circle spline and shape it around the cap. Bring it into the volume builder, and in the case of this spline, we actually want to see the spheres of voxels. So we need to select it in the volume builder, increase the radius to make it bigger, but decrease the density to reveal the spheres. I don't want spheres all around, so let's only leave the ones on the side by taking out a cube and sizing it around the spheres that I would want to remove. Bring it into the volume builder and select subtract. Make sure that you also isolate the bump and the cube because of course you don't want this to look the way that it does right now. You want the cube to only be affecting that circle spline. So make sure that they are both in a folder, both properly named as well as the folder properly named. Now let's go back to trying to smooth out the shape. Let's add a smooth and make that the upmost layer, and that means that it's going to affect everything underneath it, even the things that are isolated into folders. Let's change the smoothing operator from Gaussian to Laplacian flow, and this is going to leave the basic shape the same but smooth out the edges. Let's increase the iterations so that the smoothing happens over and over. I left it at around 5. Look at the difference as I'm checking it on and off. One thing that I forgot is that the helix should be removed from the tube, not added to it, since usually the tops of caps are dented in and the bottles itself are the ones that are dented out. Alright, now that we have our entire volume builder done, we want to make it a child of the volume measure so that we have the final geometry. But the thing that I'm noticing is that none of the smoothing that we did was good enough to remove those segments in the base cylinder. So let's go into that cylinder and increase the segments quite drastically. I increased it to 100, but you should try to do it in increments if you have an older computer, because as soon as you start increasing a lot of segments and a lot of objects, your computer could not like it and start crashing. Alright, so next we're going to make a keychain ring. This one's going to be short and simple, as we're mostly just going to be using a helix as our path, a rectangle as our contour path, and a sweep generator to generate geometry. Make the helix smaller and tighter, and bring in the rectangle into the sweep as well as the helix. Scale the rectangle down until it starts to resemble a keychain ring. The width of the rectangle should be greater than the height so that you don't have a perfectly cubed ring. And those final numbers end up being the height 2.6 centimeters and the width 5 centimeters. And in the sweep, I want you to check off banking, which gives you a curvature that follows your path. We want this to be flat, so check that off. I will stop here for a second so that you can take a look at the helix final numbers. And don't forget to add rounding to the contour rectangle. Now we're going to position this in the small hole that we made. So to make it easier for us, let's enable axis so that we can change where the axis is. And put the axis on the left side of our viewport in the side view. Turn off enable axis, and now move your ring. So much easier to position it now. You can always further play around with all of the settings if you'd like. Let's clean up our objects manager really quickly by naming our volume measure and then grouping them into a null called cap. The next thing is we're going to make a bottle by using our pencil and a lathe. Bring in the reference image and let's begin making this outline. Remember that you can alter the transparency of your reference image by going to Mode, View Settings, and the Back tab and changing the transparency there. You want the center point to be at 0. And you want to create an inner spline to give the bottle thickness. Once you're done creating your spline, you want to make it a child of a lathe. If your spline makes the lathe's geometry look weird the way that mine is right now, you can always go to your spline smooth and smooth it out. But remember that the strength is in the attributes and 100% strength is probably too strong. The last thing that we're going to do is add the inner ring to the bottle. But instead of bringing the bottle into a volume builder, let's take out a tube object and line it up with the inside of the bottle. Yours might be different, but mine ended up being 39 centimeters in the inner radius, 43 centimeters in the outer radius, and although I forgot to round out the height, it should be 44 centimeters. I also increased the rotation segments. I ended up quickly fixing the top of my bottle because it had a weird shape that I wasn't a fan of, but if yours is okay, then you don't have to do this. Now let's bring in a helix and do something similar to what we did with the cap's bottom. Size it accordingly so that it fits inside of your tube. And the same end angle that we gave the cap's helix, if you remember, mine was 1820, I'm going to give it to this helix. Once it's done, let's bring both of these objects into the volume builder. Lower the voxel size to something small like 0.3 centimeters. And remember that you can alter how the spline looks with the radius and the density. Make sure to add an SDF smooth filter to smooth it out. Put the builder as a child of the measure and make sure that everything looks how you want it. In my case, I noticed that my tube was still too sharp, so I added more segments to it. The good part about non-destructive modeling is that you can always just go back and add more things or remove more things. It doesn't matter, none of the changes that you make are final. So now it's just a matter of positioning these objects to get a nice render out of them. Make sure that you name everything you need to name and that you group things that should be grouped. For example, the inside of the bottle and the bottle should both be in a no. Remember, the shortcut to put things in a no is Alt-G. I am taking out a plain object to put as the floor and positioning the cap around so that I can get a nice final render that shows the work that we did on the inside of the bottle and the work that we did on the cap as well as the inside of the cap. Notice that I changed the axis of my cap null so that it would go inside of my null and I would have more control over how to position it. I will leave the materials up to you, but something to know is that when you have a volume builder and a volume measure, the things that you bring in together can only have one material. So you can only put a material on your volume measure and all of its children will have that material, which means that in this case, the cap is all going to be one color. And that's it. See you in the next tutorial.